Hi everyone, I'm Martin and welcome to another great edition for Astronomy for Beginners. Now I haven't done a video for some time, my apologies. Like you say, weather's not been great for the past few months, and obviously I'm getting withdrawal symptoms because of the bad weather. We're not getting much clear skies, and as we are drawing in towards June and July time, it's usually a bad time to observe the night sky, as the skies are becoming much more a rarity. We don't have a lot of dark skies up here in Scotland, as during this period of time I'll be very lucky if I get 1 hour of dark skies. So today I'm going to do a product review. Now, for people like myself, many others who live quite high up in the north of the UK and in other countries that's in that region, and the main reason is the atmosphere is very turbulent, especially between the summer months. Okay, you get a lot of hot air in the sky. Obviously, from a very hot day, alright, it's going to affect your views, particularly on planets and the moon. The other problem is, the higher up you are on Earth, particularly if I'm in Scotland, the higher up I'm near to the North Pole, the planet seems to be a lot lower in the sky. So if I was like, say I was in India or somewhere in the equator, the planets will be very high up in the sky. They'll be up in zenith. And because you're looking at, if you're looking straight up, you're actually looking at the finished part of the atmosphere. So because of that, the planet's going to be a lot more defined, they're going to be a lot more detailed, razor sharp images, because you're looking at a very thin part of the sky in the atmosphere. For us that's living in Scotland and Norway and Sweden, those sort of places, Canada, if you're high up in that region, the planets will be very low in the sky. In other words, they could be just above the horizon. And what will happen is that you're not going to get the best possible views. So, in this video guide, I'm going to show you this item. Now this here is a product from ZWO, and this is called a atmospheric dispersion corrector. Now, in high resolution planetary imaging, it's our atmosphere that does most of the damage to planets and the moon. Okay, you're going to lose a lot of resolution, and because of the scene conditions determines how good your views are going to be. Now what this device does is it will eliminate all the effects of smearing and fading of the fine details on planets, particularly if you're using a telescope like this, which is a Maxitov category, okay, equipped with the ZWO ASI 120 MC. Okay, this is a dedicated planetary imaging, and this setup here is usually good for very good close-ups of the planets and the moon. Okay, this setup here. Now, this device, when this is coupled together, will reduce the amount of atmospheric dispersion. And in other words, when you're looking at objects, planetary objects, below the horizon, now what the atmosphere tends to do, it tends to split the light waves within the spectrum. Because what you're looking at is white light, but when you're going through, when it goes through the atmosphere, it tends to split the different colours into blue and green and red. And what this effect is called atmospheric dispersion. In other words, when you're looking at an object through the telescope, through the eyepiece or your camera, you're going to get some scene effects where you tend to see much more of the blue light and much more dispersed within the red, obviously the red light. And this is called like this diffraction. And what it is because of this splitting effect, it's going to reduce the resolution of the planet details, so you're going to lose detail. So what this corrector will do, in simple terminology, this will help to cope with the atmospheric aberration, or also known as false colouring effect or fringing. And what this fringing will do is to reduce, this corrector is to reduce that effect, so that you're going to get a much more sharper, much more high quality image through high magnification or high resolution through the camera, and you should be able to see a lot more finer detail within the planets. So in theory, this should dissipate the effects what the Earth's atmosphere is doing to the actual image. What I'm going to do is I'm going to do a product review. I'm going to show you a close-up on this cool product that I've got, and I'm going to then give out an honest review, show you the workings, how it works, okay, and then I'm going to show you how would you fit this onto the telescope with a camera. I'm also going to show you a few hints and tips, and like always, I'm going to test this product myself to prove to you guys and girls if this product actually works. So like always, I'm going to give out a good honest review, test it out, and prove to you guys and girls with live images to prove, does this ADC work? And if it does work, again, you can decide for yourself if it's worth the money or not. So looking at what I'm seeing here, it's looking very promising already. So like always, we're going to test this product out, test how it performs, so you can see for yourself using a decent setup like this, okay, on this 5-inch scope, okay, and we're going to test it out what this ADC can do, okay. And if you're interested in this product, again, please contact Astronomy, okay. They sell this cool product, and also Astro also sell this ADC from ZWO, okay, at a really good price. So if you're interested in buying one of these and you see the results on the video, later on in the video, then go ahead, click on those links, okay, they're available, alright, at a good price. So what we're going to do now is we're going to take a closer look from here. So we're going to take a closer look on the ADC, the ZWO ADC, and as you can see, again, no frills box, okay, you don't need anything spectacular, but as you open it up, it's well packaged, like always, with a lot of good products. So again, it's all packaged together. We'll put the box to one side, and we'll take a closer look actually on the ZWO. Now, one thing I've noticed about ZWO products, and it really does disappoint me sometimes, is that there's no instructions whatsoever, and that's the same for their cameras as well. There's no instructions on how to use the camera or the product itself, and again, there's nothing, and so that's something that really disappoints me about ZWO. They should really reduce these the manuals and all that available, but it would be nice to see some kind of manual on how to use the product. But again, looking at the high quality ionized aluminium, the ADC looks well made. One thing I've noticed, it comes with an 1.25" nose piece, and I do like how there is a T-thread. If we look closely, that you can just see there is a T-thread here, okay. And again, it looks to me you can fit a T-ring on your normal DSLR camera. So that's a nice little touch. I also like how there's a brass fitted inside here, okay, inside there, if you can't see it, okay, there's a nice brass fitting inside there with 2 clamping thumb screws, okay, so I do like that. Now, there's also, you have like adjustment screws, okay, these are the adjustment screws for your prism. Now, if you take the nose piece out, unscrew it out, you can just see there are prisms. There are 2 prisms. I think they're grounded down to about 30 to 20 degrees. Alright, these are These are very high quality glass, multi-coated optics. I believe they're PK7 glass, which is a very good, very high quality glass. Okay, and what these prisms do is, with these adjustment screws, I mean these are screws or just normal threaded screws, okay, and you just basically slacken these out, okay, and you move these toggle switches, these levers, you just lock them in place. Now this is at the 0 position. So you have your 0 position here, where your levers should end at each end here. Okay. Now there's no clear instruction on exactly how you would adjust the ADC, how to set this properly. Now I'm guessing, reading from their sources, it's quite simply just to adjust these levers until you got the sharpest possible view. Okay. Also you have like a nylon screw here. So you have this reticle here, so you can adjust your reticle adjustment. Okay. So whatever markings you are at, you can line up the levers along these alignment markings here. Okay. So you can get your same setting adjusted. So if you are going to use it again on a different night, you can line up these markings, okay, with the levers like so, and that'll be the setting you use. However, don't expect it to be adjusted exactly how you want it, because certain nights and certain atmospheric conditions may affect the image quality. So again, one night you need to adjust the ADC periodically. So again, you adjust it to get the sharpest possible view. So what we're going to do is we're going to show you how you connect this ADC onto your camera. This is the ZWO ISI 120 MC. Okay, very easy. You can just slot this in place like so, loosen the screws here, okay, and just tighten up, and that's basically the setup, right, on your ZWO. You may wish to fit a Barlow lens. Okay, I've got an ED Apo Barlow lens, which is a 2.5 times Barlow lens. Okay, very good Barlow lens. This is from Telescope Service, and again, this can either fit inside the nose piece at that end, okay, and then slot it into the ADC. Okay, so you have that set up here. I mean, this ADC is designed for ZWO products, so ZWO cameras. However, you can actually use this ADC for a DSLR camera. So don't think that you can't use it for anything else. And I'm going to show you this. Now, to do this, you can fit the telescope directly using the 1.25 inch. Now you can get away with that, but because the camera has a lot of weight, alright, I don't really like to use an 1.25 inch fitment on there. So what I would use is a T2 adapter, okay, which has a T2 ring here, okay, which is a 2-inch format nose piece. So again, if you unscrew this part here, the nose piece, and then connect your T2 adapter. Right, so that is a 2-inch format, okay, T2 nose piece, which we're going to give out a much better clamping force onto my telescope. Also, what I found is you've got the T-ring here. Now, just be careful, because every T-ring is different. Now, here we have a Barda T-ring. Now, the Barda T-ring Right, it fits perfectly onto the ADC. Okay, without no hassle. Alright, again, this is a very high quality T-ring adapter. Alright, from my Canon camera. Now the main problem is though, not all T-rings fit perfectly onto the ADC. Now this one in particular is a slightly cheaper T-ring, and when I try to screw this in, it's very stiff. Okay, so it is the correct thread. It is a T2 thread here, and some of the threads might not screw in properly, okay, onto the ADC. Okay, I mean this is just not screwing right. So what I did with this one, I checked the threads and checked to see if they're not damaged. Now if they are damaged, then get another T-ring and try that. Okay, it's trial and error. You don't want to risk damaging the threads here on your ADC. However, these threads here, what I found it is easy just to put a little bit of tissue, a lubricant like a grease, like a lithium grease on the threads here. Okay, only a film. All right, you only need a film of grease, or you can use a WD-40, which is like a light lubricant oil, a penetrating oil. Okay, spray it on a tissue. Okay, and then using the tissue, just wipe across the thread. Okay, only thinly. All right, you don't need too much. All right, just enough just to lubricate the thread, and then just try to screw it in. It may be a bit stiff at first, but it will go in eventually. Now there's also another thing I've noticed, is while you're screwing the T-thread, these screws are in the way. So what you have to do is you're going to have to take these thumb screws off. Alright, once you take them off, okay, you just then screw on the T-thread. Like so, until it stops turning. However, this design is that the thread will start to go through, and what will happen, it will go straight through. So I would like to have seen something like where the thread stops at the end. Okay, but this doesn't, so it's a bit of a slight design flaw, because what happens is as you screw it in there, you can keep on screwing until the T-thread goes from the other side. So what I have noticed is if you unscrew this part here, it exposes another T2 thread. Flip it round, screw it onto this side. Okay, now what you see now, you see a lip here, this lip here. You can then screw on your T-thread like so. Okay, and that fits flush. So now there's plenty of thread. There's a good at least 3 or 4 millimeter thread on the T-ring itself. So now that's fitting flush. And as you can see now, a lot sturdier. And now I can attach my DSLR camera, okay, like so. We're going to line it up like so. Okay, that is now my ADC attachment with a T-ring onto my camera. However, the one disadvantage of this setup is I cannot fit a 2-inch Barlow lens, okay, on this setup. It might not work with this ADC adapter. However, if you refer to my video guide on imaging planets using the DSLR camera, I will show you how would you set this camera, this DSLR camera, to take close-up shots of the planets. Okay, so if you refer to that video guide, I will show you how you use that without using a Barlow lens. So now what we're going to do now is we're going to connect the setup onto the telescope and test out the ADC. We're back to our telescope, our Skywatcher 127mm Maxitov. First off, because this is a 2-inch format eyepiece holder, okay, you can use the camera using the 1.25 inch. However, I prefer to use the 2-inch format, okay, better clamping force. Instead of relying on just one screw on the 1.25 inch, okay, which you've just got one screw, you're going to have 2 brass screws inside here, clamping force onto the ZWO ADC. So now you've got 2 screws here, much more better clamping force, lot sturdy, and that's what you want. However, because the way the ZWO is designed, okay, we need to angle it like so, and then what we're going to do is set our adjustment screws to 0. Again, set it to 0, okay, that should give you a 0 correction, so there should be no correction added onto your views or your images. Again, using this ring is to centralize your markings, okay, if you wish, but I never bother with that. So basically, as long as your adjustments are zeroed like so, okay, you should get no correction whatsoever. You can use the existing nose piece like so, okay, and that fits your ZWO camera like so. And then what you do is you focus the image first. Once your image is nice and sharp on your computer, okay, you can then begin to do your corrections. And to do that is you just have to look at the computer screen, look at your focused image of your planet, okay, and if there's slight blurring or there's slight false colour, you just adjust each toggle, okay, bit by bit, okay, nice slow movements. Check your image again. If it's not corrected, just untwist it, slight adjustments, okay, and just do it bit by bit. And that's the whole idea, is once you get a nice crisp view and a lot less false colouring, okay, once that's corrected, okay, I mean this corrects the adjustment to 180 degrees, okay, of ADC correctment. And the prisms will do its job to try and correct the colour of your image of your planet, okay. Once it's corrected and once your image is focused, you can then begin your recording. Now the good thing about this ADC, you can actually use an eyepiece, okay, so you can actually view planets using the ADC to maximise your views, okay. So you don't need a camera, okay, to do this job, okay. You can actually use an eyepiece, okay, fit your eyepieces diagonal on there like so, and you can view with the ADC, and the ADC will also improve your views through your eyepiece. So it really is good for visual as well as just for imaging. Again, if you want a Barlow image, okay, you've got to use a Barlow 1.25 inch format, okay, and you can connect it up that way. Bear in mind, you need to refocus your image, okay. So again, focus the image, make sure you've got a nice sharp crisp focus, and then again zero the ADC, and just bit by bit, slow movements, okay, but you want to be able to see that on the computer screen to see any positive gain. So now we're going to show you how we use the ADC using a DSLR camera, okay. Use the T-ring, slot the T-ring in place like so, and as you can see here, as I mentioned before, right, I'll quickly just take this nose piece out like so, and then screw in this end here. Okay, all the way in. Okay, till it stops. What I do is take off the ADC completely. Okay, take it off completely, and basically what you do is line up the ADC like so. Okay, that's locked in place. And then what I do is put it back on there like so. The main focus is once you just where the markings are, line them up like so. Zero your ADC and just line up or orientate the camera, okay, like so. And as you can see, that's a very sturdy setup there now. Okay, so now all I do is the same principle with the DSLR. Again, using live view, because live view is going to be your best friend. You need to focus the image, adjust the ADC, okay, bit by bit, using adjustment screws. Check the image, see if it's corrected, all the false colouring and the blurring. If not, just try again, just bit by bit. And again, if you go far too much, okay, go back on itself, okay, until it's corrected. And that's how you use the ADC. So what we're doing now is we're going to wait till it gets dark so we can start testing the ADC out. It's cleared up now and we're imaging Jupiter through the DSLR camera. What we do is we're going to dim down the exposure, okay, so we can try and get the cloud belts more defined. Now as you can see now we've got the prism set up, and what we're going to do is we're going to adjust the prism, set into the 0 position, so there should be no correction whatsoever. So what we're going to do is we're going to adjust each of the metal segments on the ADC, and hopefully should improve the views of your telescope or your camera, and see what happens. Now as I'm moving each of the segments, I've noticed the minute movements on the prisms is actually shifting the image. Now I've just corrected it slightly with 2 segments on each side, and it's just corrected the false colour. What I'm going to do is I'm going to move the telescope slightly, I've started to see a little bit more detail there. At the bottom there's a lot of cloud detail, and that's good. That ADC has actually made an improvement. So what we're going to do is we're going to just readjust a little bit more. Again, the disadvantage is that the ADC tends to slightly shift the image, so you have to keep periodically just adjust each every time. Just moved it another 2 clicks. Wow. Oh, the view is getting much sharper now. Really sharp. As you can see there, I can start to see now this is well focused, because don't forget the focus is very crucial for the telescope. And already after adjusting another 3 or 4 segments on the ADC, I'm starting to see the bottom parts of the planet itself, the major equatorial belts, seem to be a lot more refined, and Jupiter's just about to start to get lower, closer to the horizon. Now that's the trouble about where I live. Because I live higher up in the UK, planets tend to be
quite low, and as you can see there, I've seen a massive improvement with the images. Astounding detail, and the actual planet itself is very steady tonight. So what I'm going to do is I'm going to do a recording of that and gain some reasonable amount of data. And what I'm going to do is I'm going to uncorrect the image, so we're going to put it back uncorrected. Again, as I'm uncorrecting the image, you can start to see already, as I uncorrected the image has gone blurred. There seems to be a lot of false colouring. Again, this is the effect which is caused by the Earth's atmosphere, and that's what happens because the Earth's atmosphere splits the spectrum. You see, again, if I up the exposure, you can see now how bad that is, and you can see the blue fringing and the yellow fringing at the bottom, and already look at that. Again, if I re-correct the image, look at that. That is a massive improvement. So just by tweaking 5 notches on one side of the prism, you can see now a remarkable difference on that image. I'm just going to centralize it. Look at that. So I've already confirmed now that that ADC does work, and already as I just tweaked it there, and it's given me a lot more detail on the image, and I can clearly see a lot of structure on Jupiter. So definitely that atmosphere dispersion corrector has worked wonders. I'm actually quite impressed. So, what do you reckon then, guys and girls? Yeah, I'm very impressed with the results as well from this ZWO Atmospheric Dispersion Corrector. I've just proven to the fact that the images have been well improved. So despite all the a few minor flaws where you get problems with, where you get the image start to shift as you adjust the ADC, you will get that, and plus the other thing is, with the ADC I noticed that you tend to lose a little bit of light, so all you got to do is compensate by adjusting the exposure on your camera, increasing the gain so that you get a decent enough image which is not quite as dim. So there are some disadvantages of using the ADC. However, looking at the images you've just seen and the results I've gained from this, how much of the views improved. Now, would I recommend this product? Yes, I would. And personally, I only recommend it if you live in an area, like I said before, I live up in Scotland. The planets tend to be a lot lower in the sky. So if you're one of these people who live in an area where the planets are quite low, then I would seriously recommend that you purchase the Atmospheric Dispersion Corrector. Particularly if you've got planets that are just above the horizon, between 20 to about 30 degrees in the sky. From the results from last night, Jupiter was around about 25 degrees in my location. Don't forget the atmosphere. If you're looking at that sort of angle, you're going to get a thick atmosphere, and that atmosphere is around about 160 kilometers of atmosphere you're looking at. If it was straight up, you would then get much thinner air, which means that your views are going to be a lot better. So again, would I recommend this product? Yes, if you live in an area where the planets are very low in the sky, then I would recommend this product, definitely. And for £132, it sounds a bit pricey, but what you're getting at is good quality astro equipment, so bear that in mind. So again, if you enjoyed this video, please give a thumbs up, and again, we're also available for Astronomy for Beginners Facebook group. Please join that group. There's a lot of useful information and tips from our members. Okay, we've helped a lot of people into astronomy. So far we've been seeing some fantastic images produced by absolute beginners, and it just shows you that these videos here play a massive part of helping people out in the astronaut community, getting the most out of their budget style equipment, and it just shows you these videos help you achieve some amazing results. So if you're interested in this product, order online to Tring Astronomy or Alto Astro or any good astronomy shop that will sell this product from ZWO. So again, if you like my video, please give a thumbs up, and so if you want to keep updated with the latest Astronomy for Beginners videos, please subscribe onto my channel. There's a lot of great videos on there. You will gain a lot of hints and tips from there, a lot of good advice. And if you'd like to subscribe onto my channel, click on this link here, click on this link, and thanks again, thanks for watching, and clear skies to you all.